Hi guys, welcome to Science Tech for Fun. My name is Mr. Fassan and we're gonna cover today resistance of a wire. So we're gonna demonstrate how to assemble the equipment involved and we're gonna take some readings, okay? You will see this practical is very simple, one of the simplest in physics content, okay? So let's start with the materials. For this practical, we will need a voltmeter. Some schools can have digital as ours. Some schools can have analogic, doesn't matter. So we have a voltmeter, we have one ammeter, we have a set of batteries. Here we have 4 batteries summing 6 volts. We have 1, 2, 3, 4, 5 banana cables, 2 crocodile clips, a meter ruler with a piece of wire, nicromium wire here attached, and we're gonna use it as the measurement between the distance on the crocodile clips. Okay, so let's start assembling. So always we're gonna start assembling from our power source to the circuit and returning to the power source, okay? If you're gonna start with the positive, if you're gonna start with the negative, is absolutely up to you, doesn't matter. Although, when you're assembling, you need to always have in your mind from where you start and where we're gonna finish to keep in the ammeter and in the voltmeter the right polarity, okay? I prefer to start from positive and return in the negative, okay? So the first thing I need is a piece of wire. I'm gonna connect it here, and then my wire I'm gonna connect with a crocodile clip. The crocodile clip will be used for me to click and clip my wire in one position and make contact between the metal of the wire and the metal of the clip, okay? The best way to do it is to find a rounded position. For example, we're gonna start here in 30, okay? Because we can work between distance of 5 or distance of 10. So if I want to start with 10 centimeters apart between the 2 crocodiles, I can start from 30 and the next clip gonna go for 40, okay? So if I'm gonna start from 20 centimeters apart, start from 30 and the second one gonna go in 50. So it's easy for calculations. So the first part here is connected. Now, my second crocodile clip, I'm gonna attach into the banana cable. And as I said, we're gonna start with 10 centimeters. So 30 to 40. Okay, so there it is. Now, I will connect my banana cable into my ammeter. Why is important to have in mind where you start in terms of polarity? To connect here and not be negative, okay? Negative reading is still a reading, but is not what we expect. We want positive. So I started from positive, connected my wire. This turn now in part of the circuit, so this is still positive. Come here and it's still positive. So I will pick one of these 2 polarity. If this is positive, so carry on here, connected here, come all this way as positive, I will connect this in the positive. Then I will go for negative, so I will place another wire here coming from negative and connecting here in the negative part of my cells holder, okay? So now I have current running here, and how can I check? I can just turn my ammeter on. So here is reading 0.67 amps, is reading positive. Just for demonstration, I'm gonna show you if I have inverted the polarity. So rather than placing in the positive as I did, if I had placed it in the negative, you will see the numbers still the same, or about the same, but now is negative, okay? So to keep your results straight, always have in mind, positive, go to the positive, negative, go to the negative, okay? So consider it as all this system here is just one wire. So if it's coming from the positive, all the system is like one wire is going to the positive. And then the single wire will return to negative. Now I need to measure the voltage, okay? For the voltage, I will have to connect it parallel with the measurements I want to do, okay? So the ammeter is in serial inside the circuit. So the ammeter is in the middle of the circuit, and now the voltmeter will be parallel with the equipment I want to measure the volts, okay? I want to measure specifically this piece of wire, okay? This 10 centimeters of wire. Why? Because I know I have 6 volts coming from my power supply, okay? The 4 batteries summed together, I have 6 volts. Although part of this energy gonna be lost here in this piece of wire, and I don't want to check how much is being lost. So I will connect. Remember, again, positive, negative. It's coming from the positive until here. So the positive need to be connected here. Negative will be the other one. Okay? And then I'm gonna turn this on. As you can see, we have a positive reading. And then you can say, wow, this is not supposed to be all positive, because you said before that this was like a big long wire connecting to the ammeter. Yes, but this was related to the ammeter. When we talk related to this parallel measurement we're doing here with this piece of wire, I also gonna have positive and negative, okay? Positive and negative in terms of the current or the energies is going inside from one side and returning to the other side, okay? So I need to keep this in my head, considering that the positive is coming to the side, so I need to connect here in the positive. And the negative will be the other side, okay? Just for a demonstration, if I change the poles here, I will have a negative reading. At the end, the number will be the same, just the negative or the positive will change, okay? But to make easy for you, always have in mind the polarity. If by mistake you misconnected, you just need to invert the polarity, okay? So, starting with 10 centimeters, I know, I can see that in this circuit, I have 0.65 amps running, and I have 1.24 volts here. So what I'm gonna do now, I'm gonna increase the distance. I started with 10, then I'm gonna go for 20, okay? So we're gonna disconnect here. Remember, I started in 30, it was 40, now I'm going for 50. And let's see what happens. Here in the ammeter, I have 0.53 amps. And here, I have 1.91 volts. Now, we're going to increase the distance again. So it was 20 centimeters apart. We're going to increase for 30. So I'm going to unclick this part. And from 50, I'm going to 60. The amps change now for 0.43. And the voltage change for 2.38. The last measurement, 4 centimeters apart, from 60 to 70. Amps reduced for 3.7, 3.6 is oscillating normal, and the voltage increased for 2.70. Okay, so you can see that when I increase the distance, there is a relation between amps and volts. The volt is increasing, the amps is reducing. Why? Because I'm increasing the resistance. The resistance is how difficult it is for the electron to run inside the circuit. So when I increase the distance, it's getting more difficult for the electrons to run between these two clips. So if I have less electrons running here, the amps, the current, will reduce. For the other hand, my voltage increased. Okay? Did you see how easy it is? Thank you for your time, for watching. If you like, give a thumbs up, subscribe, turn the bell on. See you next time.